that over forget about this. And you can make an interpretation for that. So this interpretation gives you that condition. It gives you the theta should be between 0 to pi. Okay, this is this is just one example about the inner product. What about the cross product? In physics, several times you have a two vector in this one plane, but you can make a combination of that, and the combination will be out of the plane. For example, you have a particle. This is the location of the particle, r, and this is the velocity vector or the momentum vector and velocity. And suddenly the particle started to escape from the plane. Huh? Suddenly the particle started to escape from the plane. So you will get the particle here out of the plane. Why? Because a new quantity introduced as the angular momentum, and this non-zero angular momentum make able the particle to leave the plane. So you see that here we introduced a new symbol. So I want a few minutes to talk about the cross product. So cross product is not inner product, is a product is a vector. It's actually this is vector. You have a dot of two quantity gives you a number. But cross product of the two vector gives you a vector. So I want to just define the vector. So if you have an A, and A is AIEI. You remember the EI was the unit vector and that was the component. And if you have a B, B is BJEJ or BIEI, no problem. I define A cross B as the vector which the component of that is cyclic. What does it mean? So if I want to find the first component of this vector, I need to go to the next index. So after if you fix it 1, after the 1 is 2, so it will be A2, and after 2 is 3, minus A3B2. Huh? And the C2 will be A3B1 minus A1B3. C3 will be A1B2 minus A2B1. So this is called cross product. So Ci is sigma Rj Bk minus Rk Bj Ei. That's it. There is another representation of the cross product using the matrix and determinant. I don't want to write it that because I want to keep the continuity. So I don't want to use that. So just cross product help you to introduce a new concept, new mathematical concept. Can I remove that because it just gives you the component. Ci is AJBK minus AKBJ, and you need to understand that if I is 1, so J will be 2, K will be 3, and they just circulated to each other. If you want I2, So it will be seated 2, so it will be 3 and 1. So they will circulate. I don't like this notation. I want to write this notation like that. Yes. Just instead of this 1 here, I introduced a parameter. I call it epsilon. Instead of this -1, I introduced a parameter. Do you know what is the useful of that? The useful is that now I have the equation, just the indexes appear here. Indexes. And the fact is that this is minus of that. So I introduced a factor that if I change the second pair of the index, so it will be negative. So epsilon 1 to 3 is minus epsilon 1, minus epsilon 1, 3, 2. Just change it in car and j, so j and car will be changed. So this object is called Levi-Civita symbol. So this is the one of the place that by introducing the index, you can make the equation more beautiful. So this is the last equation I will write today. So I want to tell you that forget about your easy way thinking of the vectors and try to learn that if C is R cross B, you can write C sigma Ci Ei, and instead of the Ci, I want to write epsilon ij k ij b k. But you see that the j and k are summation actually over j and k. One time you put a j2 and k will be 3, and next time you change a j to 3 and k will be 2. So just this is the what I want you this is the definition of the component of the cross product. You have a 2 sigma here. You know, I think you prefer maybe to do the cross product easily, but that's what you will do in the calculus. So this is not the calculus. So I will take, I learn you something new. So the component of the cross product will be written like that. If you want C1, just put 1 here, and try to see that which value of the j and k they can run. When this is a 1, j can be 2 or k 3, or j can be 3 and k 2. Just 2 possibilities, and you can get, and forget about the sigma. Sigma is just to remember into mind that when you fix at your I, so you have it, for example, 2 type of the possibilities. So that is the reason that I use it j and the k sigma. Just to if you don't need, you can remove it and just read it. Actually, in advanced level, we don't write this 2 sigma. We use a summation convention, call it ancient summation. We say that if the index repeated 2 times, it means that there is a sigma over that. J appear here and J appear here, so it means that it was a sigma. So you can write or not write, but I understood that it was a sigma. So this is the Ci. And look at that. If you have something like that, this is called a back cap. Back cap identity. Back cap identity. You already know that. What is the A cross B? A cross B is the vector called C, and the component of vector is given by that. I want you to use this definition and prove that. Because you already know that what is A dot C. A dot C, for example, is sigma I 1 to 3, A I C I, no? few minutes before I talked about that. And you know what is the something cross something is I written here, all the information. Try to prove this backup identity, but you will need some information about the epsilon. That I will, and this epsilon is very tricky object. This is not the normal number, you see that. When you change it, the index, so it changed the sign. So this looks like some object we call a tensor. But so I don't stand on the world of tensor now because I told you I want to follow something which I think is good for me. So just, I don't know before you see any proof of this or no. There is no easy proof for that. But one possible proof is that to use this definition. Just accept that epsilon as some parameter. So that's all. So I think for today is enough because. So let's just see where we can go.